Hi, I'm Andrew, and in today's video I'm going to try to fix my mistake from the last video. I told you that I bought another bike for 15 euros. It was irreparable and rusty, but among other things I'm going to use its motor. This is the rusty bike. The motor seems to be from another bike. I've seen this model of motor on Dutch bikes like Batavus and Sparta, but that's not important. What's important is that the bearings don't make noise, and more importantly is the compatibility with our controller. So I set about dismantling the wheel and mounting it on our bike. I encountered some minor difficulties. One of the nuts was a bit difficult to unscrew, but my biggest concern was compatibility. The original motor on our bike had a strange 6-pin joulet, and the one on this one had the normal 9-pin joulet. I moved the wheel from one bike to the other so I could unscrew a little more the nut that was hard to unscrew, needing a little more space on our bike. The fork mount is much thicker on our bike, the fork being aluminum unlike the other one which is steel. On the left is the normal 9-pin joulet, and on the right is the atypical 6-pin joulet. The cable is damaged because it rubbed against the frame, the rubber protection being inside the frame, but it doesn't matter because I'm going to cut it anyway. Not much later I realized that cutting the cable on the bike was a mistake, because the cable on the wheel was already stretched, because extended is too much to say. I strip the wires and connect them together with quick connectors. As I said, I'm not 100% sure that the new motor is compatible with the controller. Pop the connector, slide the battery and turn the bike on from the screen that I refurbished 2 videos ago. And it seems that the motor is working fine. Here I noticed that the cable on the wheel is not only coiled because it's too long, but it's also cut and spliced in. At first I thought it was just a long coiled cable, because on my orange Batavus bike, which has an identical motor to this one, the cable connector goes all the way into the frame, so the cable is quite long. But I'll deal the cable part later. Now I want to move the original black rim onto this functional motor. For that I'm going to start by marking the spokes. I'm making a mark to know how far the nipple was screwed. This will help me balance and center the wheel faster after I mount the new rim. With those plastic tools I start taking the tire off, but before completely removing the tube and tire I removed the valve fixing nut. This rim tape has a very strong adhesive and it's a bit fragile, so I brought the heat gun and heat it. It came off much easier. Using a common spoke wrench, a flathead screwdriver and another spoke to remove the nipples, I unscrewed all 36 spokes. Some were easier to unscrew, other harder, but in the end I succeeded. Now I had to do the exact same thing to the original wheel, except that the tape came off much easier and I also took the spokes of the motor hub. I aligned the hub with the new rim while the spokes are still attached to the hub. This will guide me maintaining the correct pattern. I placed the hubs so that the spokes can easily reach their respective holes on the rim. I took a spoke that axes the hub outward. I followed the marks that were on the hub and went with it in the right side. I took the next spoke from the right side of the previous one with inward hub exit. I counted 5 empty holes counterclockwise and I put the spoke in the 6th. I did the same thing on the other side, only that in mirror. So now the spoke that goes in the left side exits the hub outward and the right side inward. Everything is mirrored on this side. In the 2-cross pattern, each spoke will cross 2 other spokes before reaching the rim. To do this, I took the second spoke from the hub clockwise with inward exit and inserted it into the second rim hole counterclockwise of last spoke from this side. Each pair, the first spoke counterclockwise from the hub with an outward exit goes into the 6th hole clockwise from it. And that's it. I repeated this process as it worked around the wheel. With all the spokes laced, I tightened them until the mark that I previously made. Use the spoke wrench to adjust the tension evenly across the wheel. As you tighten the spokes on the right side, the rim moves slightly to the right. Tightening the left side brings the rim back to the left, but untightening the left side brings the rim to the right side, because untightening works the other way as tightening. I adjusted the tension until the rim was centered with the hub. It's a time-consuming process, but patience is the key to get a perfectly balanced wheel. With the spokes evenly tightened, I turned my attention to the motor cable. Upon inspection, I noticed the cable had been cut and reconnected in the past, but the connections weren't soldered. This could lead to unreliable performance, so I decided to rewire and solder the motor connector properly. To ensure the final cable wouldn't have a bulky section where all the soldered connections lined up, I straggled the cuts on the wires. This method spreads out the soldered joints along the length of the cable, preventing a concentrated bubble that could interfere with routing or cause stress on the connections. After stripping the wires at staggered points, I carefully soldered each pair together, matching the correct color codes to ensure compatibility with the controller. This process requires precision, as a solid solder joint is critical for electrical reliability. After soldering, I protected each joint individually using heat shrink tubing, then covered everything with a larger heat shrink tube for additional protection and a clean look. Before shrinking the larger tube, I poured some epoxy inside to ensure waterproofing and durability. This is a cable for the taillight, but we don't need it. It comes from the AXA headlight, but since we have a direct connection from the controller, it's unnecessary, so I removed it. If I had noticed that the cable was stretched at this point, I wouldn't have cut the other part, but it was already too late. It is what it is. Now, the last step, pouring sealant into the larger tube, and that's it for today. If you enjoyed today's fix or found it helpful, make sure you hit that like button, subscribe and stay tuned, because I still need to do a lot of cool things on this bike. Thanks for watching and I'll see you in the next video.